I inherited this particular Commodore 64 after a chance conversation with a friend from church. He said it was just lying around in his garage taking up space, and I was quite welcome to it if I wanted it. I reluctantly accepted his offer and casually made my way around to his house to collect it. I've never owned a Commodore 64, so I was quite excited about this acquisition. Although the unit looked in fairly good condition, albeit slightly browner than I remember them being, I figured it'd be best if I checked the power supply before I plugged it in. These two pins at the top are the AC lines, so they're both 9 volts AC, and the bottom pin, the one directly opposite the notch, is ground, and the pin clockwise to the ground pin is the offending 5 volt line. So first, let's make sure the meter's on DC. We'll set it to the 20 volt range, and let's check this line. It's a bit fiddly this, I don't want to short things out. I'm just going to take it off here a second. There we go. So I'm getting 5.2 volts off the DC line, and this is not under load as well. So we're definitely in the range of seriously you need to think about getting a replacement power supply. So just out of curiosity, let's check these AC lines. Switch my multimeter to the AC setting. It's still keeping the 20 volt DC range. So just check these top two pins. Getting 10 volts on there. I've been assured that that's regulated internally by the Commodore, so that's probably less of an issue. But we've got 10.1 volts on the AC line, and we have, just to confirm, over 5.2 volts on the DC line. So the voltages were within spec, just about. I figured it was safe to plug the Commodore 64 in, so I connected it to my television and plugged the power supply in, and nothing. Black screen. Absolutely nothing. The standard Commodore 64 power supply is a known motherboard killer. So as a side mission, I decided to build a power supply based upon a design by Sven Peterson. This will be the subject of another video. So now it was time to crack open the case and figure out what was wrong with this Commodore 64. Following a guide by Sven, I ran some diagnostics using my scope, and much to my surprise I discovered that some of the address lines on the processor were stuck high. So I've encountered this before on Spectrums where one or more of the chips are not disabling and holding the address lines high. So here you can see a trace from A0, which looks perfectly normal to me, and here you can see a trace from A1. It's being held at about 4 volts. You can almost see the pulse, but it just looks wrong. The easiest thing to eliminate from our investigations is the SID chip, because it's socketed, and the Commodore 64 will work just fine without it. So I removed the SID chip and it still wouldn't boot. The next possible culprit is the PLA, so it was time to get a bit more invasive and unsolder that. Unfortunately, after removing it and testing the Commodore 64, the address lines were still stuck. So what's next in my plan to restore this lovely little machine? Well, I've got a plan. It's a 6-point plan, and I'm already part way through that. 1, remove the SID chip, see whether or not we can get the machine to boot without it. That didn't work. Then after checking the board, and noticing the address lines stuck on the CPU. 2 was to desolder the PLA. That's another point of failure. After I wasn't expecting the machine to boot with a screen after removing that, but on the scope the address lines are still stuck on the processor, so it wasn't necessarily the PLA per se. So 3, desolder the RAM chips. Any of those could be holding the address line I. I've tested those, so they're here. They all check out fine. I've tested them in a 4164 DRAM tester, so I know it's not necessarily the RAM chips. Next, it's the logic and multiplexer chips. So reading up on this in the forums, the MOS chips are prone to failure, so any of these could be holding the address lines high. I've got a replacement set of 74 series chips, so the plan is to remove these, put sockets on the board, and put the new chips in, see whether that unfreezes the address lines. Oh yeah, it's worth mentioning sockets. These boards can only take so much soldering and unsoldering. They're quite old boards, so generally when I remove a chip I'll stick a socket in before I put the new chip in. It just makes it easier in future. If anything fails, you don't have to get the soldering iron out, you can just whip the chip out and put a new one in. So that's point 4. 5, if that fails, it's desolder the ROM chips and verify them in an EEPROM programmer against a known ROM dump. And if that doesn't fix the problem, if we've still got stuck address lines, maybe it's the CPU. So I'll be whipping that out and putting that in an op tester circuit to see whether or not it's the CPU at fault. Hopefully I won't have to go that far. Of course, if all of that fails, I'll have to start looking at the VIC-2 and these peripheral I/O chips, and possibly look at recapping the board as well. All the fixes mentioned will be the subject of future videos in this series. If you've enjoyed watching this video, then please subscribe to my channel. Thank you.